what does it mean when we say that space is curved? That's a really good question. To kind of show you this, I got one of my daughter's birthday balloons, and this has been donated to Science Today. We wanted to show you what curvature means and how it manifests itself. So again, space isn't a something. In fact, in Einstein's theory of general relativity, you can almost remove space altogether. That was something that Einstein himself sort of said. So even though we talk about space curving, what we actually mean is something a little bit more abstract than a rubber sheet bending. So the surface of this balloon is curved. What I'm going to do is I'm going to draw a triangle on this surface here. And I'm going to draw the best possible triangle that I can. I'm going to start at the north pole of this balloon here, whatever that means. There we go, and I'm going to draw a line down to about the equator of the balloon. And notice I've drawn a wicked good straight line on that balloon, wouldn't you agree? So then I'm going to come over and I'm going to draw another straight line on that balloon there, just across the equator there. So now we have two sides of the triangle, and then I'm going to pull this side back up. We have a triangle here. Now, if you remember anything about Euclidean geometry, which is a fancy way of saying 8th grade geometry, you'll remember that the interior angles of a triangle should add up to something special. We've been using this throughout the semester, last semester. The interior angles of a triangle add up to 180 degrees. So you might be surprised when you're looking at this triangle that something actually appears to be wrong. If I look at this side right here, you can see that is a 90-degree angle. That is a right angle right there. I'm going to put a little box there to indicate it. I'm going to come up to this side there. Can you see how that's also a 90-degree angle? So I'm going to put a 90-degree angle right there. So already we've used up 180 degrees here. So we know that there's going to be something wrong. Come down here to this side. Can you see how that's also 90 degrees? So I'm going to put a triangle, a right angle right there. Here's a triangle where the interior angles add up to 270 degrees. There are 3 right angles inside of this triangle. The reason why we're able to violate Euclidean 8th grade geometry is the space that we're in is curved. When those geometric rules break down, and they break down in specific ways, we can be assured that we're living in a curved space. Now this is a 2D analogy of a 3D thing. The space that you're sitting in right now is curved. The way that we detect that is a little bit different. Einstein said that the way you could detect space, a curved space, in one of his books to the public was, let's say you have a sphere. Let's ignore the triangle for a minute. And you measure the radius of the sphere and you calculate what the volume of that sphere is with 4/3 pi r cubed, and you keep that number and set it aside. And then you fill the sphere with water, and then you figure out how much water the sphere could actually hold in volume-wise. You take that number and you compare it with the number that you originally calculated, and that, if those two are in disagreement with each other, you're living in a curved space because Euclidean geometry has broken down in some way.